All right, this lecture is going to be discussing milling, machining, cutting operations. The first cutting operation we're going to get into is cutting linear movements with G01. This can be found on page 31 in your text. This code is very similar to the G00 rapid movement. The difference between them is that the G01 requires a feed rate. That feed rate will be inches per minute. G01 will cut a straight line and is modal. The feed rate is also modal and can be stated on a previous line. We will first be using G01 to feed into our cutting depth. We'll be at a position away from the part and we'll call up a G01, a negative Z depth, and then a feed rate. This will allow us to be at our cutting depth and then feed into our workpiece. We won't be plunging, but we will be feeding into our workpiece from away from the part and then engaging with a smooth transition. If you look at this program example, we start off at the beginning of the program. We have a safety line, our work coordinate system. We call up a tool change, turn the spindle on, and we wrap it to a part away from our cutting location. Then we turn on our G43, our tool height compensation. We wrap it to Z height, 100 thousandths above the workpiece, and then this final line here, G01, Z negative 0.125 at a feed rate of 10 inches per minute. So we are away from the workpiece. We're dropping down to a negative Z depth by using our G01 code, and then we'll be engaging our workpiece with the rest of the line movements after that. The following video will be discussing a couple options to cut our desired workpieces. The first one is to factor in the radius of the tool and move to that position. And then the second option will be using color compensation. All right, so going off of our program example, we wrap it to point X -1, Y -1. And if this is a bird's eye view, a top view of our workpiece, we want to be going to right here. All right, and there's a couple different ways that we can program our tool to get to this location right here. That's what we're going to talk about now. We're going to talk about compensating for the radius. And then we're also going to talk about using color compensation, which will lead us into our next topic of this lecture. Color compensation will offset the center of our cutting tool and shift the tool automatically from some parameters that we give the machine. All right, so looking at this information I wrote here on the left, we want to use a 1/2-inch end mill, and we're going to wrap it to point -1 on the X and -1 on the Y. So looking down at the top view, we move to right here with our cutter. This is the end mill. All right. Well, the center of the end mill is at this location right here. Now, if we want to move over to cut this square, this 1x1 square, now we would have to either use two options: offset the radius of the cutter in our program, or use color compensation. All right, and let me show you what I mean by this. So if we don't factor in the radius or use color compensation, and we move to this next location to cut up, and if we move to location -0.5, -1, half of the tool is going to be taking off more material than we want to. We're going to have 1/4 of an inch, this 1/2 inch divided by 2, cutting into the workpiece. So in order to make this a 1 by 1 square, we have to factor in the radius. So looking into this little program over here, we move to the location x -1, y -1. We move to a z height of 2 inches above the workpiece, calling out the height compensation code. Then we wrap it to 0.1 above the workpiece, and then we're going to feed down to a Z cutting depth outside of the workpiece. So since G01 is modal and so is the feed rate, we would want to compensate for the radius and move over to x -0.75, y -1.0 to offset our tool so we could cut. So we would want to be cutting, say, here with the side of the cutter. So we would offset the radius of the tool in order to cut that edge and not take off more material than we want to. What I've done here is known as offsetting the radius without cutter compensation. I know what the radius of the tool is, and I've added that number to my program to offset the radius of the tool and use the outside diameter for a cutting edge. This is offsetting the radius without cutter comp. Now this is okay for simple geometry like I have drawn here, but as you get into more complex parts, the mathematics behind finding the point to point can be a bit tricky. That's where we're going to want to start to use cutter compensation. And these next slides will help show some of the rules of cutter compensation and some of the benefits of using cutter compensation. Cutter compensation information can be found on page 60 in our textbook. Cutter compensation is a code to offset the center of the cutting tool and shift the tool the distance of the tool's radius. This allows us, the programmer, to program the workpiece to the part geometry. It is a lot more convenient, has less mathematics, and is going to be our friend once we learn how to use it properly. 3 codes to know for cutter compensation. G40 is cutter comp cancel. We've talked about this a little bit at the beginning of our programs. We're going to talk about how to turn it off at the end of our program. And then cutter comp left, G41, and cutter comp right, G42. So in order to use G41 and G42 correctly, the machine needs to know the diameter of the tool to compensate for the radius. So what we do is we enter a dimension under the diameter geometry column in the tool offsets page. If we're using a 1/2 inch end mill for tool 1, we would put 0.5 under diameter geometry in the offsets page, and this will allow the controller to recognize the diameter of the tool. Then once we enter the code into our program, we'd say G41 with a location and then a D value. That D value is going to mark whatever tool number you're using and the offset in it. All right, so moving forward on using G41 and G42. The last slide mentioned how the machine needs a cutting tool diameter in the diameter value of our offsets page in order to compensate for the tool. But when we call up this diameter, it's going to be just like a G43 code, but with the G41 code. And you can see on this line here, G41, that I have a D value. The D value is going to reference in our diameter geometry column of our offsets page of what the diameter of the tool is. This way the machine knows how much to compensate in order for us to cut. I also mentioned the 2 cutter comp codes, G41 and G42, how they compensate the tool to either the left side or the right side of the cutting action. Notice that I have used G41. Okay, so this is going to compensate on the left. What this means is the direction of our cutting path, the tool will be compensated that the radius of that diameter to whatever side that we call out. In this instance, it's cutter comp left. So I move to my location down here on the bottom of our 1x1 square. And originally I started off at this location here, x -1, y -1. Well, in order to turn cutter compensation on, we need to do a line movement that is at least half of the cutter's diameter. Let me repeat that. We need to do a line movement at least half the cutter's diameter. So if we start off at this location right here, x -1, y -1, and then we move over to this location, -0.5, -1.0. We're moving at least half of the diameter of our end mill. So we're actually moving 0.5, and our diameter, or our radius, is 0.250. So we're moving more than half the cutter, which is typically what we want. This is called a lead in. And when we turn off cutter comp and we come off the workpiece, we'll be doing a lead out. That would be G40. That will be deactivating cutter comp, and that's the same motion. We lead in with at least half the cutter's diameter, at least half the cutter's radius, and then we lead out with at least half the cutter's diameter. So looking at our program here, we wrap it to the first location right here of -1.0 in the X and -1.0 in the Y. We drop down in our Z location. All right, we turn on G01. We do a feed rate of 10 inches per minute. And we drop down to our cutting depth right here. So we move from this location, the G00, and we want to turn on cutter compensation left. And we do that with a line movement, which is still modal. And we call out a D value to reference the diameter in our tool geometry. And then we move to the X -0.5. That is at least half the cutter diameter. Right? If we're using a 1/2 inch end mill, half of the cutter diameter is 2.5. So we are moving actually 0.5. So we have enough room to turn cutter compensation on. So once we move to cutter compensation, once we move to our new location using cutter comp, we can now program to the part's geometry, and the tool and the machine will compensate for the tool for us. So you see my next line right here. We go to X -0.5 to Y 0.5. So we're climb cutting, which is going to give us the rigidity that we want in the CNC machine. But you can see, looking at the 1x1 square, that we're on the left side of the cutting path. All right. Then our next line, X 0.5, Y 0.5, we are staying on the left side of our cutting piece, left side of our work piece during our cutting path. Now our following line would be X 0.5, Y -0.5. G41 is modal. The linear line movement is modal. The feed rate is modal. So we continue down here on the left side of the cutting tool, the left side of the workpiece with our cutting tool. I just want to make sure that you guys understand this, the the comping of the left or comping to the right with G41 and G42. Think of it of how you're driving your car and the direction that you're going. So we like to, as I mentioned before, on CNC machines, normally climb cut because the machines are rigid enough to use these cutting conditions, right? Mostly conventional cutting will be used on finish passes, but we're going to stick with using climb cutting because of the rigidity and the cutting accuracy that we'll get. So if we start down here, this is our tool. And if we're traveling this way, climb cutting, we're using G41 because we're on the left side of the workpiece in our tool path. Now, if we were to use G42 and we're heading this direction, then our tool would be on this side over here. And we'd end up cutting the workpiece too small. Well, we could use G42, but we would have to conventionally cut, and we'd have to come from this way. So that would be G42, and then continue around as we conventionally cut. Just a few things to remember about using cutter compensation. G41 is cutter comp left, G42 is cutter comp right. We need to turn on cutter comp with a G01 straight line movement. And the very important thing, we must lead in and lead out with a movement at least half of the cutter diameter. This next topic will be an introduction to circular interpolation. Circular interpolation will be circular motion in any plane using G codes G02 and G03. The direction of travel will determine which one of these codes you use. G02 is clockwise and G03 is counterclockwise. A couple other things to remember when we're using G02 and G03 is that when we use these codes, we will program to the end of the arc. And also in our line of code with whatever G02 or G03 code we use, we need to give more information with our line of code. All right, circular interpolation uses I, J, K values or an R value. The R value is for radius. It is most likely used with a corner radii. We will not be using it in this class. We will be using the I and J value. These are incremental values from the start point to the arc center. I is an X value and J is a Y value. Now I'm going to go through a couple of examples for you guys. All right, guys, we're going to do a quick example of using circular interpolation. Now, if you guys remember the key points, G02 is clockwise and G03 is counterclockwise. Okay. A couple other key points to remember is that we program using these codes to the end of the arc. So wherever our end point is of the arc will be our point. And we're also going to give it some I, J, or K values. They are incremental values from start point to the arc center. All right. So I is the X value, J is the Y value, and K is a Z value. Well, we're not going to be changing our Z values for any of our programs, any of our cuts. So we'll be focusing on I and J. I just want to remind you guys of that, I and J, and they're incremental values from the start point to the arc center. I'm going to give an example of that right here. All right. So here is our workpiece. It is a 2-inch diameter circle. And I've started our program over here. Here's the beginning of the program. And I fast forward. Now I am going to rapid to X 2.0, Y 00. So I'm out here in space. Okay. I'm out here in space right there. Okay. So if this is a 2-inch diameter circle, that means that if this is 00, that this point right here is going to be X1, Y00. All right, so let's say we're using a 1/2 inch diameter end mill. And we want to use cutter compensation with this too. So we're out here in space. We're at this location right here, X 2.0, Y00. We do a line movement down to a negative 100,000 Z depth. So now we can create this boss by cutting into the workpiece. Now we're going to turn cutter comp on. This is cutter comp left. We will be using climb cutting. So now we turn cutter comp on. We move to the part geometry at X 1.0, and we call out a D of 01, suggesting that we're using tool 1 to do this workpiece. So now our new cutting location will be right here. And that is right there. Okay, because we have cutter compensation on. We're going to be traveling left of the workpiece, and we need to put our next line of code in. So let's erase some of this. All right. So if you guys remember, we programmed to the end of the arc. So we need to call up a G02 because we're moving to this position right here. G02, we're going clockwise right here. Clockwise, G02. And we're moving to the endpoint location X00, Y negative 1.0. Well, we have to include an I and a J value too. So these letters would go right here. I ran out of space, so I'm going to put them right there. So this is an I and a J. Right? So these incremental values are from the start point, which is right here, to the arc center, which is right here. That's the arc center. These are incremental values. So the I is an X value, and the J is a Y value. So incrementally, on the X, we are moving -1. So this would be -1. Are we moving anywhere on the Y-axis? We are not. So this would be J0.0. So since we have created this arc, we now have to move to this point over here. So our tool is going to swing cutter comp left to this location here. And we program to our end spot. G02 is a modal code, so we don't have to repeat that. So we can just put the endpoint location, which would be X negative 1.0, Y 0, 0. Now we have to do our I value and our J value. Okay, so incrementally from our start point, do we move in the X? We do not. So this is 0, 0. Well, we do move in the Y-axis, J. Incrementally, we go positive 1.0. Right? So you got to remember, every time that we move incrementally, we are restarting a 0. Okay, so our incremental movement, this is our 0, 0 here. So if we move up to our swing location, we're moving up in the positive Y. When we were at our first location over here, we moved because we reset 0 for incremental movement. Our swing point was over here. So that is a negative x value. That's why in our first line, it was negative. In our second line, it was positive. All right. So continuing on with machining this boss, we're going to swing up here to our next location. G02 is modal, still on. X to our end location is 0, 0. Y is positive 1. And we need to get I's and J values. Well, for the I, we reset 0 here for incremental movement. And we're moving to our swing point this way. So that is a positive 1.0. And there is no movement on the y-axis. So this is 0, 0. And our last position, our start position right here, we're going to continue to swing. This is also G02. It is modal, still on. We're going to X 1.0, Y 0.0. And we don't move anywhere in the X axis. So this is 0, 0. And our J is going to be a negative 1.0. Because we're coming down -1 to our swing point from our beginning point. All right, guys, I pulled up discriminator, and I'm going to show you the circular interpolation sound discriminator to give you guys an idea of what it looks like. All right, so I've opened up discriminator, and then I went into new, and I opened up a new page. First thing I'm going to do is save this. I always want to save my programs, save my work, make sure I don't lose anything. So I'll just go to desktop, and I'll put G02, G03 example, and I will save this. Okay. So I began my program, and I start off with a percent sign, and I have written here circle example in parentheses. Anything in parentheses, the controller will not read. So all the notes that we put in our program will be in parentheses because the program will not read it. All right. It's kind of going forward, you can see that I have my safety line right here. I have my work coordinate system. I call up tool 1. I have my spindle on. I move to a location. My G43, my tool height. I wrap it down to 100 thou above the piece. And then I do a line movement 100 thou into the piece at a feed rate of 10.0. And then I turn on cutter compensation left, and I move to the location X 1.0, calling up D01. Now, discriminator will not show you if there is a cutter comp error. All right, we will see these in the Haas simulators that we will use in lab. But discriminator is great for checking your geometry and checking your point to point. It won't show you all the errors that the controller will pick up. All right, so we're going to go through and we're going to program this, and just how I did in the example before, and see how everything comes out. Now, if I want to see what my points look like, I can go up here to where it says plot with full viewer. I can turn this on. I can change the amount of screens right here, display. I can go 1, 2, or 4 screens. I'm going to stick with 1. I have my machine set on a mill. All right, so I'm out here in space. If I move down on the line, you can see these dotted line brings me out to over here on the right. And then I do a line movement over here to this location. So my next line is going to be a G02, X 0.0, Y -1.0. And you can see that it looks like it's just a diagonal line. Well, that's where you have to put the I and J in. So I is -1.0 and J is 0.0. And you can see our arc is there. We'll jump to the next line. X negative 1.0, Y00. There is our diagonal line. We'll do our incremental movements. So our I is 0.0 and J is 1.0. And you can see we have another circle. Keep going. Now our third point will be up here in the y-axis, y positive. So this will be x 0.0, y 1.0. And that will be an I of 1.0 and a J of 0.0. And our last point will be X 1.0, Y 0.0, I 0.0, and J negative, because we're moving from the incrementally in the positive Y down to our swing point, which is 0, 0. So that's negative 1.0. And then we could turn off cutter compensation. We need a line code, get that active. Because if you remember, G02 is a modal code. So this was modal and on for these positions. We'll call on a G01 and then G40 X 2.0. We can wrap it up to a safe Z location because we're away from the part. We can turn spindle off, and then we can return program to the beginning of the program with M30 and then a % sign. Okay, that's a very basic program for just doing a circle boss feature. Hope you guys were able to follow along.